Hey, what's going on, guys? Let's do this problem right here. The question is asking water flows in a pipe where at point 1 pressure is 160 kilopascal, velocity is 1.5 meter per second, and the elevation is 16 meter. And the point 2 pressure is 175 kilopascal and velocity is 2.3 meter per second, and they are asking for the maximum possible elevation at point 2. So let's see how we can do this. So in this case we are going to use the Bernoulli equation. Before that I am going to collect the information that is provided. So we have the pressure one, that is P1 is equal to 160 kilopascal, and velocity 1 is equal to 1.5 meter per second, and the elevation, so let's say elevation is Z, Z1 is equal to 16 meter. And information about point 2, we have the pressure 2 is equal to 175 kilopascal, and the velocity 2 is equal to 2.3 meter per second, and we have to find the C2, that's the question. So we have the formula for Bernoulli's equation, from the Bernoulli's equation, that is P1 over rho G. So since this is water, we know that density of the water is 1000 kilogram per meter cube, so that's not a problem. P1 over rho G times plus V1 square over 2G, V is velocity, and then elevation plus elevation, and I'm going to equate this 0.1 to 0.2. So P2 is equal to, and in this case we have to make an assumption that water is incompressible, so that's the assumption. And P2 rho G over rho G plus V2 square over 2G plus Z2. So Z2 is what we are going to find. So let's rearrange this equation. So Z2 is equal to, I can direct P1, let's put this one first. Okay, so we have Z1 right here, so let's put this one first. Z1 plus, so we have P1 in the other side, so P1 minus P2, P1 minus P2 over rho G, and then we have V1 in the other side, so this is going to be V1 square minus V2 square over 2G, and that's all we have. Now all we have to do is simply plug the values, and that's going to give us this one. So we have that C1 16 meter plus P1, that is provided 160 kilopascal, minus P2 175 kilopascal divided by rho G. So rho is 1000, G is 9.81, I can say 9.81 kilonewton per meter cube. Same thing like kilogram per meter cube multiplied by meter per second square. Like this is the thing you're gonna get. The unit is not a problem, like there are many conversion in units. You can try if you want, but many different way to write it, so it's not a problem. So plus V1 is 1.5 square minus V2 is 2.3 square divided by 2 times 9.81 meter per second square, right? So let's leave the unit alone. Okay, so if I calculate this value, this one comes out with 16 minus 1.53, and all the at the end we are going to get meter at all of this right here. So if you divide this Pascal, you can expand the Pascal as pressure is force over area, so Newton per meter square, and all will cancel out and you will get meter at the end. So this is going to be 1.53 meter minus 0.155, and if you calculate this one comes out to be 14.3 meter, and that is the maximum possible elevation at point 2, and that's the final answer. I hope you guys liked this video. See you next time.